And that's how it goes. You never ever know about the NWO. Deep behind enemy lines for September 2nd, 2020. NASA, yeah, here we go. NASA picks potential missions to study space weather. More Earth changes and geopolitical upheaval, and another update to the New World Order. Whoops. From the No Link News Desk, move over, harp-tards. You'll not see this news or earthquake prediction from Doomsday Dutchie's Magic 3D Earthquake Crystal Ball first. So in case you miss it, or want to wait and see sloppy seconds from dumbass Doomsday Disinfo Dutchie, let's get to the science of things today. Back in 1998 on Coast to Coast AM, Mitch Petros rocked the global warming Agenda 21 community with his space weather equation. And it went something like this. Sunspots trigger solar flares. Solar flares are cosmic rays or highly energetic charged particles. These highly energetic charged particles then trigger a shift in the Earth's magnetic field. A shifting magnetic field triggers shifting oceans and shifting jet stream currents. Shifting jet stream currents and shifting oceans triggers extreme weather and human disruption. Mitch Petros wrote the book called Solar Rain on how these cosmic rays were going to increase in the coming years and pose potential devastation on our planet. And in 2012, Mitch Petros rewrote the equation to include charged particles, how it affects our core, how the planet expands when it heats, and how it shrinks when it cools, triggering earthquakes. If Doomsday Disinfo Dumbass Dutchie has got anything to say, we're just a little ahead of the game when it comes to earthquake forecasting, just to let you know. Yeah, here at No Link News. So let's get into the news this morning and show you what I mean. Since Disinfo Dumbass Dutchie that predicts earthquakes hasn't been up to speed as quickly as science of cycles and earth changes occurring. Yeah. So here we go. Let's transition over here. Let's get to the science of things, everyone, on space weather.
UAH is getting some help from the National Science Foundation and NASA for a space project. The two agencies awarded the university over $3 million to build software models that are useful for predicting weather in space. The project's team includes several organizations, including Marshall Space Flight Center.
Yep. So NASA picks potential missions to understand space weather. The sun sends out constant streams of charged particles of energy, which drives complex space weather systems on Earth, and it can affect spacecraft, astronauts, the weather, and even the geodynamic effects of the Earth including earthquakes. Yeah. The concept studies of missions to help understand the dynamics of the sun that constantly change with space environment. The information will improve understanding about the universe as well as the key information to help protect astronauts and satellites. Dr. Nikolai Pogorelov is a distinguished professor at the Utah's Department of Space Science and Research. It was working to develop an open-source solar atmosphere inner heliosphere software model useful to predict space weather. Let's see here. There we go. Each of these medium-class Explorer proposals will receive $1.25 million to conduct a 9-month mission concept study. Following the study period, NASA will choose up to 2 proposals to go forward. Each potential mission has a separate launch opportunity and time frame. NASA has taken big steps to launching these new missions to help understand how the sun interacts with space environment around our planet. Space weather has a huge impact on both communication signals, space exploration, geomagnetic storms caused by solar matter. For instance, it could lead to less accurate GPS. Solar particles could also be hazardous to spacefarers. In particular, they could damage the DNA within an astronaut cell and cause cancer. So there we go. Right there. Yeah. So we've never really been to the moon, have we? Or is it still within our protective bubble of outer space radiation? Solar particles. Their mission to provide a global view of space weather systems. It will use several tools to observe how solar particles interact with Earth's magnetosphere. We'll show you some of the things they've got planned. Here we go. Yes, sirree. Oh, we need to go to this one here. Let's watch this again.
Hi, I'm David Sybeck from NASA's Goddard Space Flight Center in Greenbelt, Maryland. I'm here today to tell you about an exciting new mission, STORM, the Solar Terrestrial Observer for the Response of the Magnetosphere, recently selected for consideration by NASA's Medium-Class Explorer program. STORM is the first standalone mission to observe the big picture of space weather. STORM does that by taking simultaneous solar wind measurements and global images to quantify the response of the Earth's magnetosphere to the sun. STORM carries a full complement of 6 instruments that simultaneously measure the solar wind input and the response of Earth's magnetic field, the shimmering aurora, the radiation trapped within near-Earth space, and the outermost reaches of Earth's atmosphere. STORM has its own array of cameras that look up at the nighttime sky to observe the aurora. STORM will be the first satellite to fully characterize the circulation of energy in near-Earth space that powers space weather and has devastating effects on satellite and ground-based infrastructure. Our team is honored to be among the missions under consideration by NASA. We look forward to working with the community on STORM's exciting and novel science and to bringing space weather science to you.
So there you go. STORM is the first of the 5 proposals NASA is planning on choosing. This mission plans to provide a global view of space weather systems. It will use several tools to observe how solar particles interact with Earth's magnetic sphere and figure out how an event in one region of the sphere affects the other. There we go, doomsday, duchy. Maybe he's got all this figured out on his magic 3D earthquake crystal ball. He can see this stuff. As the helioswarm is the second proposal by NASA, the nature of turbulence in space plasmas. Helioswarm will use 9 small sat spacecraft to take measurements that'll help us understand the solar winds. Here we go. We'll move over to this now.
Fundamental yet poorly understood. My name is Harlan Spence. I'm director of the Institute for the Study of Earth, Oceans, and Space at the University of New Hampshire. I'd like to share my team's excitement about the science goals and implementation of our mission concept called Helioswarm. Helioswarm will explore the mystery of plasma turbulence, one of the fundamental yet poorly understood building blocks of how our sun affects the solar system, and, by extension, how stars influence their environments. Helioswarm targets the long outstanding question of how plasma turbulence heats particles. Without turbulence, we know that the universe would be far cooler than is observed. Helioswarm will solve this mystery. In addition to the exciting science goals, Helioswarm's implementation sparks the imagination. It employs a swarm of 9 spacecraft whose swarming orbits simultaneously sample the solar wind in a novel way needed to finally reveal the physics controlling plasma turbulence and particle heating. The Helioswarm team is excited and raring to go. Hello everyone, my name is Harlan Spence. I'm director.
Okay. Thank you, Harlan, for your input on this helioswarm. The next in the phase of NASA proposals is the multi-slit Solar Explorer. This mission will use spectroscopy techniques to help unravel the mysteries behind the processes and events happening in the sun's atmosphere, including the cause behind solar eruptions such as solar flares. As we were pointing out, sunspots trigger solar flares, and in the coming years coming up, the sunspots are predicted to increase as the solar cycle 25 peaks somewhere between 2024 and 2025, where a peak of sunspot activity and solar maximum activity is forecasted to take place. So let's hear what Bart DiPonto of Palo Alto, California at Lockheed Martin has to say on the MUSE project, Multi-Slit Solar Explorer.
Hi, I'm Bart DiPonto at Lockheed Martin Solar and Astrophysics Lab in Palo Alto, California. I'm the PI of MUSE, the Multi-Slit Solar Explorer, and my team and I are really excited to be selected for a Phase A study. MUSE is a spacecraft that orbits Earth and will observe the sun's atmosphere in extreme ultraviolet lights, and it will address 2 long-standing problems in our understanding of the sun: why the sun's atmosphere is millions of degrees hotter than its surface, and how solar flares and eruptions work. These are space weather events that can lead to effects here on Earth like northern lights or disrupting power grids. MUSE has 2 very novel telescopes on board. One telescope that takes images of the sun's atmosphere at very high spatial resolution, seeing smaller details than we've ever seen before. And the second telescope is a really innovative spectrograph that splits up the light into its different wavelengths and then allows us to measure remotely the temperature and velocities of the solar gas. MUSE will do this almost 100 times faster than previous instruments, and this is crucial for finally addressing these big questions we've had for almost a century. We have a great team and unique instruments, and are really excited about MUSE and the science it's going to address.
Okay, thank you for sharing that latest information, Bart DiPonto. Okay, how do you say that? Anyways, now we know the techniques by the spectroscopes, yeah. The fourth in a line of tools being proposed by NASA will be the auroral reconstruction cube swarm. For all you harp-tards out there, maybe you should now get a conspiracy on how this may be a major indication that you might look for in causing tornadoes, Dutchie, with your HARP rings, or maybe, earthquakes with HARP. Yeah, it's been a leading, conspiracy for many of those dumbasses like Doomsday Disinfo Dutchie, who had no clue what the High Altitude Aurora Research Project was all about. Now that we now have new HARP observatories being proposed by NASA here coming up soon. Watch this now, everyone.
Hi, I'm Christina Lynch, a professor of physics and astronomy at Dartmouth College in New Hampshire. Our mission is called ARCS, an acronym for Aurora Reconstruction Cube Swarm. We'll be flying a localized swarm of 32 CubeSats, small rectangular spacecraft about this big, to cross over the northern and southern aurora lights and measure the signatures of electricity and magnetism in space. We'll fly 32 of these over a dense array of imagers on the ground that will look up at the northern lights from Alaska. And at the same time, we'll take an MRI, a tomographic image of the charged particles between the spacecraft and the ground array. We want to understand the information contained in what we see when we see the northern lights, and use it to better understand the space environment. This becomes a valuable, accessible diagnostic of our planetary environment, and is knowledge we can transfer to observations of aurora on other planets like Jupiter and Saturn. The aurora is a beautiful piece of our natural world. We're excited to explore it, and it's a privilege to have auroral observations be our field of study. This is an exciting time for small spacecraft as well, and the opportunity to make truly multi-point local observations of our near-Earth space will open up new understanding of our planet's environment.
There you go, you harp-tards. You ready? Yeah. You ready to make earthquake forecast now? With this latest technology? Yeah. As the Aurora Reconstruction Cube Swarm. Yeah. We'll provide a comprehensive picture and the drivers and response of the auroral system, and to get a better understanding of our magnetic sphere. That was HARP's proposal to begin with, dumbass harp-tards, but who am I to point out? The fifth proposal by NASA in observing space weather will be Solaris, revealing the mysteries of the sun's poles. Solaris proposes to observe the solar poles and collect data on light, magnetic fields, and movement on the sun's surface. We know and track this too, as that data also transfers over to our magnetic fields, and it moves and evolves to show a period of great solar activity approximately every 11 years. As this mystery reveals, the solar cycle 25 coming up. Many are claiming we may be seeing a magnetic polar reversal on the sun, and also leading to one here on Earth.
Hi, I'm Don Hassler from Southwest Research Institute in Boulder, Colorado, and principal investigator of the Solaris mission to reveal the mysteries of the sun's poles. Solaris will explore one of the last unseen places of the solar system, the poles of the sun. To do this, Solaris will first travel to Jupiter and use Jupiter's gravity to slingshot out of the ecliptic plane and fly over the sun's poles at 75 degrees latitude. Imaging the poles of the sun from such high latitude promises to reveal clues to understanding how the sun's polar magnetic fields and flows shape the solar activity cycle. Just as our understanding of Jupiter and Saturn were revolutionized by polar observations from Juno and Cassini, our understanding of the sun will be revolutionized by Solaris. The Solaris team is a diverse international team of world-class scientists and engineers, and I'm extremely proud and excited to be working with them and with NASA to mature Solaris as part of the MEDEX program. Hi, I'm Don Hassler from Southwest Research Institute in...
All righty. So there we go. Huntsville scientists will lead national study in space weather. Hold on a second. So before we move on and finish up this latest news, NASA says it chose to the potential missions based on the feasibility and that the cost for the investigation for 2, it will ultimately pick out of the 5 and capped at a $250 million grant. So NASA, whether you believe it or not, more information about this can be seen at NASA's website, nasa.gov/sun-earth. What does this all mean? Well, as I've been pointing out, the sunspots trigger solar flares. Solar flares trigger extreme weather and earthquakes, as pointed out yesterday's solar geomagnetic storm. KP5 index peak and spike in magnetic induction into the Earth's crust that triggered a 6.8 earthquake in Chile and multiple aftershocks. As you will see, them preparing for, and possibly the big one in the Northwest, Cascadia, Washington, Seattle, British Columbia. Here's a simulation of a possible tsunami, earthquake event. They're preparing for Doomsday Duchy. The simulations, they're preparing for this already, way ahead of the game. The big one that you haven't forecasted or accurately predicted in your dumbass earthquake predictions every day. Yeah. Hadn't happened yet, Dutchie. But
new video shows us how a tsunami could impact Washington's coast. The State Department of Natural Resources rendered these simulations, and they shed some light on which communities could really be at risk. King 5's Jessica Jenner Castro walks us through them.
The State Department of Natural Resources released several simulations today to help educate people along coastal communities about the risks of flooding. So take a look at Grays Harbor County first, and the idea is that a magnitude 9 earthquake erupts at sea along the Cascadia subduction fault zone, and then you can see those tsunami waves slamming ashore, wave after wave colliding with the coast. Ocean shores in Westport completely covered. Waves enter Grays Harbor, eventually flooding those low-lying areas, including Hoquiam, Aberdeen, and Cosmopolis. And then some 8 hours after the quake, you can see just how deep the water is here in the red areas, 10 feet in these dark red areas. Also want to show you what scientists think would happen in Puget Sound. You can see that tsunami make its way down the strait, then take a turn south. When things finally quiet down about 5 hours later, there is a moderate amount of flooding in the south end near the entrance of Hood Canal and the Everett area. Important to note that in both examples, waves come and go over several hours. In the event of a real emergency, it is important to get to safer ground or even on top of a higher building in the affected areas. Back to you.
So you never know. No, you don't. When the big one's gonna hit. British Columbia, the West Coast Doomsday Duchy. Never know. We haven't forecasted it yet, even though many of you are ahead of you, a little slow, aren't you? They're a little ahead of you, aren't they? Okay, let's move on to more of the space weather. Where the heck? What the bloody heck is going on? Oh, okay. No thanks. I don't want that. Maybe this will work it in. Oh, I'm just trying to center up the screen here for you before I hit the latest on this webinar for space weather.
Aurora, but they're not aurora. Such is the case of Steve, a topic I'm really passionate about and that maybe you have seen around. We have recently discovered that Steve is not aurora, which makes it even more interesting and help us to highlight the importance and the impact of space weather on Earth. Thank you.
Thank you, Bea. I agree with Howard that it's quite a thrill to see Aurora in person. It's now time for questions about this last section. What questions do you have for these presenters? Bethany?
Thanks, Kelly. Yeah, we've got a couple of really good questions. And Carrie, the first are kind of directed to you. There's two that are pretty similar, so I'll kind of combine them. So first, how much lead time do you need for a major radiation storm when astronauts are on the surface of the moon? And then what are the plans to protect the crew if solar particle event were to happen?
Well, I think how much lead time we need and how much we would like to have might be two different things, and how much we're able to get. But what we're working on is trying to get something that's an all clear forecast, meaning that there's nothing threatening on the sun, and so we would like to be able to have a 24-hour all clear forecast, such that we can tell the flight director and the crew members that there's very little concern for the next 24 hours to continue operations. If there is a large region on the sun that is threatening, we would like for the models to be able to improve, to be able to give us these, in the next 8 hours or so, you could potentially see a large event, and to have confidence that that large will actually come to fruition, so that we don't have a lot of false alarm rates. You can imagine it's very expensive to have these missions up there, and we don't want to make the astronauts stay inside from a very important EVA or other operations that they need to be doing for an event that doesn't happen.
Great. Well, thank you, Carrie. Mark, this next question is for you. Do power companies take their own measurements of magnetic storms?
Thank you. That's a good question. So power companies all use the space weather information from SWPC here in the U.S. and in Canada they use Space Weather Canada. Power companies, many also have geomagnetically induced current monitors on the system, so they'll use GIC measurements and then can base some decisions on that or understand the environment a little better with that. Some companies are introducing magnetometers into their areas, so putting magnetometers on the ground. But primarily, those are not for operator information as much as they are for after the event, going back and working to validate their system models. So you want to have good information of the magnetic fields near your system, and then with some GIC information and your system models, you would try to analyze and validate that model and see how everything makes sense. So there is some measurement information that operators are using, but in terms of our mitigation, our operating procedure standard, it's really the Space Weather Prediction Center is the primary source of the information that the U.S. power grid operators are looking to.
Great. Thanks, Mark. Nathan, question for you. What's the impact of reverting to a non-optimal routing due to a space weather event?
Yeah, so when we operate those flights over the pole, as you saw in my first graphic, we are operating very close to the limits of the airplane. So a Newark to Hong Kong over the pole is, a 15+ hour flight time. Well, if we're not able to use the polar route, there's another route that you can use that's just below the polar latitudes, adds another 30 to 40 minutes to the flight. And that's the difference between being able to operate the flight nonstop or having to plan a technical stop or a fuel stop along the way. And one of the things that over the last few years, the airlines have had to deal with is new crew duty restrictions, crew fatigue management systems that we've had to implement. So if a crew is not able to operate the route as normal, they become illegal to operate the route, period. And so we essentially have to change crews in another city, and it causes a pretty significant disruption to that flight, as well as all the flights downline of it on that aircraft. So obviously safety is our primary concern, and we would cancel a flight rather than try to operate it at some sort of margin. And so our system and our policy and our procedure are very attuned to being able to manage these types of events. But yes, it's if we get caught up in one of these events, it's most likely going to be a canceled flight or one that is significantly delayed.
Thanks, Nathan. Let's see, Bea, this next question is for you. I've had a couple of folks chime in and want to know a little bit more about Steve.
So Steve is this purple-like arc that occurs equator of the aurora lobe at a lower latitude. So people will more often see it because it's where more populated areas in North America and South America are. This purple structure looks really like an aurora. It moves extremely fast. But when we studied it with one of the NOAA satellites, we realized that there is no particle precipitation associated with Steve, which means it's the ionosphere that is creating the luminosity locally.
Okay, thank you. And another question that came in for you, actually, I guess it's a two-part. In the Northern Hemisphere, where do you recommend to go to see the aurora? And then when are they most visible?
So the aurora is an always present phenomena. Whenever we have a clear atmosphere and low light contamination, we will see the aurora. The most dynamic aurora that happens after what we call a substorm can happen several times per night. We need it to be dark, so the winter in the polar regions is the best time. And in terms of where, I will highly recommend an area called Whitehorse in Canada. It has some of the most spectacular images that I have seen of the aurora are coming from that area, but any other place in Canada, like Alberta or Alaska too, are very good places to observe the aurora in the Northern Hemisphere.
Thank you. So now we're going to open it back up to questions from the entire panel, from the entire webinar. So I'd like to go back and, Bob, ask you a question about, sorry, let me scroll back up here, about extended kind of long-range forecast time. So are there ways being researched to extend out that long-range forecast time?
Yeah, I think so. In the space weather business, it really does, going back to what I said, it starts with that eruption. So sometimes when I explain this, it's hard to do in the short version, the 5-minute version. Sometimes it's more useful to think about this as like a volcanic eruption rather than a hurricane where we've made great progress and those systems have some momentum. Space weather really is an eruption-driven system. So what are the limits in that? I'm not sure I could say. I have high hopes that we'll get to some of these pre-eruptive signatures, and a lot of very bright minds out there working on those issues. But really, for the immediate future and for the near future, I think we're really still in that kind of that whole sequence that I described. I mean, certainly One of the biggest things we're trying to get to is getting that magnetic field information ahead of time to increase that lead time on that geomagnetic storm phenomena. But although we're working on it, I don't think there are any major paradigm shifts coming in the near term.
Great, thank you. And next question, Terry, this is related to observation, so I'll throw it your way. Are there observation satellites that are going up, planned U.S. missions or international partners that could give us more data points?
Yes to all of those. We rely heavily. One of the satellites I mentioned was the NASA ESA SOHO satellite. We rely heavily on a lot of the NASA satellites that are launched because their primary purpose is for scientific investigation, but very often NASA has put in a real-time download from those satellites, and very often those measurements are also useful for our forecasters and for our models. And in addition to that, there are a number of international missions, both from research agencies like international space agencies, but also from our partner operational space weather organizations. And they're putting up energetic particle sensors, magnetometers, imagers, various instruments that we, as much as possible, then try to incorporate into our models and our products and services.
Great, thank you. Bill, I've got a question that's come in for you. Do you think there is a way for us to be less reliant on systems that would potentially be affected by space weather? Sorry about that. Is it possible to protect these systems somehow from the impacts of space weather?
Yes, and that's a big part of our approach to building resilience. It's kind of a two-pronged approach, and the grid is a good example. The grid industry folks will develop operational procedures in response to space weather warnings and forecasts. But the second prong of that approach is how much can we engineer around the problem? Obviously, if we can build transformers that are more resilient to the geomagnetically induced current, we are in a better place. And maybe Mark can chime in on that, but there's certainly efforts underway to ensure that the grid is more hardened to protect against the geomagnetic storms. Mark, would you agree?
Yeah, definitely. I think that was one of the reasons why the Federal Energy Regulatory Commission and NERC took the approach that they did with a operating procedure standard and a planning standard, where you're looking in operating, mitigating in real time, but in the planning, you're looking downrange and trying to find where opportunities to harden the system are for the design basis event that we're going for. So yes, I definitely agree.
And just to point out one other technology applicable here to this question is GPS. GPS systems were considerably more vulnerable several years ago, but certainly with single frequency, with dual frequency capability and other advances in the GPS satellites, we've mitigated a lot of, certainly not all, but a lot of the vulnerabilities to space weather.
Well, thank you both. This next question, I think, is probably best suited for Carrie. How do we protect astronauts from cosmic rays?
So from solar energetic particles, we can help protect them on the MPCV vehicle, or the vehicle exploration vehicle that's going towards the moon, that will transfer the crew members to the moon. We have them get into a shelter and take all the stowage, and they pile it around them to produce a shield for a solar particle event. The galactic cosmic rays, on the other hand, are very energetic, and there's really nothing we can do about protecting the crew from them on a vehicle with such little mass.
Got it. And another question for you. Historically speaking, were early manned flights conducted with the knowledge of potential impacts of space weather? And then when was space weather first taken into account during spaceflight missions and satellite construction?
They were aware of space weather, and they were aware of particularly the radiation belts. The Apollo astronauts and each of the Apollo missions had radiation detectors on them, and they sent back the data as they went through the radiation belts, which were of primary concern. I'm sorry, what was the remainder of that question?
When was space weather first taken into account during spaceflight missions and satellite construction?
All right, so in terms of when we take it into account for crew members, I think it's more seriously taken into account for these longer duration missions since we've had the ISS up there for the last 20 years. It was a concern during the shuttle days, but of course those were very short missions. So I think it's been more of a concern for the longer duration missions, and has gotten more and more eyes on it since then, simply because it's more radiation exposure for longer periods of time.
Great, thank you. And that, Kelly, it's probably about it for now. We've heard so many wonderful presentations today and some really great questions. And thank you all for contributing to today's webinar.
Yes, thank you, everyone. That wraps today's 5-minute thesis webinar on space weather. Many thanks to our panelists today, and I hope you all in the audience have enjoyed these excellent presentations as much as I have. At the end of this session, a few brief questions will appear on your screen. Please take 1 more minute to respond to these. Your feedback is crucial to help us plan future webinars like this one. And also, as a reminder, this webinar was organized by the NOAA Central Region Collaboration Team. And if you'd like to learn more about us, check out our webpage at www.regions.noaa.gov/central. And it's on that website where you'll be able to find the recording for today's webinar. We're going to post it early next week. And you're welcome to share it once it's posted with anyone you'd like, teachers you know, space weather enthusiasts. If you have any questions, please send an email to bethany.perry@noaa.gov. Thanks again, everyone, for your participation, and have a great day.
Well, thank you very much, Bethany, for that presentation and webinar on space weather. I just want to point out that to bring everyone up to speed today, yeah, we had a space weather event over the last couple days. Hold on a second. Let me see if I can get what I do. I didn't do it right, did I? Oh, man. Okay, here it is. Let me transition back over here. I want to show you the magnometer here that we were all checking over and watching and pointing out how the spike and fluctuations in the Earth's magnetic field and electromagnetic reconnection occurring in the earthquake in Chile points out exactly, yes, sirree, there's no doubt about it. The spike in electromagnetic activity occurred exactly when we saw the plates slippage occur. Yeah, the major epithrust, what they call, thrust earthquake, 6.8 in Chile. This magnometer proves how the spike in electromagnetic energy works its way across and down into the crust and triggering explosive earthquakes. As a matter of fact, it's just as explosive as the electromagnetic energy that's being energizing the Earth's crust and the minerals inside. We were going through that and showing you how that all worked in yesterday in the play with the magnetic field triggering earthquakes. But also, before I close out today's show, I don't want to miss and pass up this news here. This mystery the other day up in Liverpool. I don't know if anybody's seen this or heard about it, but reports were they heard a mysterious huge boom shook their homes across Merseyside. Mystery, still don't know. Homes across Kirby and beyond reported had heard lights flicker and windows rattle. After a massive bang, mysterious boom woke up residents. So what sounded like an explosion in the early hours of the morning was a mysterious earthquake event that didn't make it on Doomsday Dutchie's magic 3D earthquake crystal ball, left many scratching their heads. Yet is what this was. They don't normally see these sort of things, but they saw flashing blue lights in the sky. So my point would be to think that these mysterious booms, yes, are space weather connected by the fact that we have meteors and asteroids flying by. And let's see if we can go to Google News to confirm whether or not fireball sky. Let's just type in the UK and see if Google have anything interesting. No, nothing pops up there. Well, I thought I saw something purported meteor shower. This is a purported meteor caught broad daylight. Fact check. This video meteor shower is fake. Creating using animation software. So there you go. You never know. There's also false claims that people can predict earthquakes too. And, coincidentally, during a geomagnetic storm, taking credit for an earthquake you predicted 2 weeks ago doesn't seem to match up with the data that I just provided with the geomagnetic storm activity. But based upon some idiot in France, yeah, you never know. Yeah, as always, I've never know. Patriot Broadcasting and Liberty Tree Radio Field Reporter number 8510. God bless the Republic. Death to the New World Order. We are on the march. The Empire is on the run. We shall prevail.
In Maya, we need to pray to the sun. We need to pray to the cosmos, because the sun wake up your memory. With the Mayas, in the Popol Vuh, in our sacred book, say, when Tepeo and Gugumats, they were here, they begin to watch how the Creator begin to do formation of the earth, of the Mother Earth. So Tepeo and Gugumas, they've been watching. So difficult to understand this, because where they were, Tepeo and Gugumats, they were in some place in the cosmos. And then that, so they know the beginning of everything. What the Popol Vuh, they don't say, the monkeys, they were watching how the Creator had been doing the world. No? They say Tepeo and Gugumas. And Tepeo is the first creator for everything.
Por eso,
That's why
lo que estamos hablando,
what we're talking about,
ustedes y yo,
you and I,
ese es el despertar de
that
la
is the
conciencia.
waking of the consciousness.
Hemos de sentirnos
We must feel
personas importantes
like important people.
antes de pasar por otro lado.
Before going
Quiero
by
dejar una frase del
to
momento.
something else, I want to leave a phrase with you for this moment, please.
Este es un secreto para cada uno de
This
ustedes,
is a secret for each and every one of you, for your family,
para sus pacientes,
for your patients
en su comunidad.
in your community.
Porque muchas preguntas,
Because
ya
a lot
desde
of people
cuando
ask,
me siente la energía
what should I
baja,
do when I feel my energy's
cuando
low?
me siente una energía
When I
negativa,
feel negative energy?
¿qué hago para
What do
renovar?
I do to renew it? To renew myself?
Tomar la energía del Padre Sol,
Take the energy from the Father,
dar
the
el
Son,
movimiento del ojo,
and give it the movement of your eye.
porque el ojo nunca tiene un movimiento propio,
Because the eye never has its very own movement.
para mirar
To look
arriba,
up,
abajo,
down,
los lados,
to the
la
sides,
cabeza.
and to the head.
And Gugumats is second, but one and another is duality. So how we're going to wake up the memory? Only working with the information of the cosmos, not believing in theories like Darwin.